Hi, welcome to Number Club. This is Year 1 Pure, Chapter 1, Lesson 1, and we're talking today about index laws. So let's get cracking. So, index laws are how you deal with powers, okay? Whether you're dealing with them through multiplication, division including brackets, or things like fractions or expansions. So, you should know from GCSE how to deal with questions like these. Things that you need to know are that if you have x to a power multiplied by x to a different power, you add up those powers. Okay, and if you divide, then you subtract those powers. So if you have x to the n divided by x to the m, you get x to the power of n, take away n. So the rule is if you multiply and add the powers, if you're dividing, subtract the powers, provided that your base number is exactly the same. So if this was an x and this was a y, there wouldn't be anything you could do with it. You just have to write it as x to the n over y to the m. Okay, so let's get cracking with these. The big tip for this is to deal with each type of value separately. So to deal with the numbers separately, the x's separately, and the y's separately. Deal with everything separately and it'll all come together in the end. So first, 3 times 2 is 6. Then we have x to the 7 multiplied by x to the power of -4. That would be x to the power of 7 added to -4. We should know that a plus and a minus will turn into a minus. 7 take away 4 is going to be 3. Okay, so we get 6x cubed. And we'll get y to the power of 2 plus y to the power of 2 plus -2. Now 2 take away 2 is 0. So we're going to get 6x cubed y to the 0. Now we know that that has a value of 1. Anything to the power of 0 is equal to 1. And so you don't need to write that down. In fact, it's best off if you don't. So just leave it as 6x cubed. Okay, next. With divisions, often when you were lower down the school, you'll have known that obviously you need to divide, but it's easier to look at when you have it horizontally, okay, rather than one above the other. You should be able to deal really with when it's vertical, but if you can't, then horizontal is the way to go, and so you should rewrite it out flat. And often that will make a little bit more sense to you if this is something that you struggle with. 10 divided by 2 is 5, x to the power of 5 take away -2. 5 take away -2, which will be the same as 5 plus 2. So it'll be 5x to the power of 7. If you rewrite it out flat, it's often easier to see what's going on with that. Okay, next. What happens if you've got a bracket being involved and then a power applied to the bracket? Well, if you have ax to the n all raised to the power of m, you use the power on the number and then multiply the powers. So use the power times the powers. Use the power times the powers. Use the power times the powers. And so with this chunk here, we're going to have 3 squared x to the power of 3 times 2, which is 6. Okay, and that's still going to be divided by 2x to the power of -3. Now 3 squared is 9, x to the power of 6 divided by 2x to the power of -3. Now does 9 divide by 2? Well, no, not really. It can come out as 4.5, it can come out as 4.5, but it's really confusing to have 4.5x to the power of blah blah blah. It looks confusing to have that unless you bracket it, which you don't really want to have to do. It looks even worse to have 4.5x to the power of blah 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 blah. Now if you have a fraction, whether it's top heavy, bottom heavy, whatever, and it's followed by some algebra, you should leave it as a fraction. 9 over 2 does not simplify, so leave it as 9 over 2. X to the power of 6 take away -3 is 9. So we're going to get 9 over 2, lots of x to the power of 9. That can also be written as 9x to the 9 all over 2 if you wanted it to. Those are exactly the same thing as each other. Okay, but you must not use 4.5 or 4.5. It looks so confusing. So let's move on again. Next, expansion and simplification. Now this looks very, very scary, but you'll recognise that what you've got is a pair of single brackets and then another pair of single brackets. The only thing to be scared about is that, okay? Watch it. Watch out for that negative that's in the middle. That's the only thing to be careful with. So we have 3x to the power of 7 multiplied by 2x to the power of 3. Well, 3 times 2 is 6x to the power of. Add up these powers. 7 plus 3 is 10. Remember, it's just multiplication. 3x to the power of 7 multiplied by negative 3. Well, 3 lots of negative 3 is negative 9x to the power of 7. Negative 4x cubed multiplied by negative 2x. So those two negatives are going to multiply together. Be really careful with that. If you've got a negative here, all of the signs in this bracket are going to change. So negative multiplied by a negative is going to create a positive. 4 times 2 is going to create 8. And x to the power of. Now, if there's no power here, it's a 1. If it's not on, it's a 1. And so you get 8x to the power of 4. And negative times positive will make a negative. 4 times 2 will make 8. X to the power of 3 plus 7 is 10. Okay? Now that looks like it's as much done as it can do, but these terms here, they can be collected together because we've got the exact same amount of x to the power of 10s. We've got the exact same power with the x's. So we have 6x to the power of 10, take away 8x to the power of 10, which is going to be negative 2x to the power of 10. And these won't collect together, and they won't collect together with either of these either. Okay, it has to be exactly the same power for it to be collecting together. We have 6x to the power of 10s, take away 8x to the power of 10s, that's fine. But then as soon as we start counting in x to the power of 7s, they won't work with these to collect together in any way. So we get negative 9x to the power of 7 plus 8x to the power of 4. Any order with these as well. So if you wrote those bits first and then you wrote negative 2x to the 10, that's absolutely fine. Okay, next up. So 3 questions here, and these are really, really, really important. The first one is pretty simple. The next one is incredibly, incredibly important. Okay, so we'll get cracking with the first one. Look at the coefficients. Do any of them simplify? Do we have 4, 5 and 2? Do they have a common factor other than 1? Well, no, they don't. We can divide both the numerator and the denominator by x. Okay, the lowest matching power is what you can divide out. So if we've got x to the power of 7, x to the power of 2 and x to the power of 1, you can take out the lowest power of those. Okay, you can divide that out. So we're going to get 4x to the 7 divided by x, which is going to be 4x to the 6. We're essentially just going to take a power of 1 off every single power that we've got, plus 5x to the 1, if you wanted to call it that, all over 2. You don't need that 1 on there, but some people like to have it. That is simplified, and that's absolutely fine. You can go a little bit further, and you can split this numerator up. So you could have called it 4x to the power of 6 over 2 plus 5x over 2. 4 over 2 will simplify, so you could call it 2x to the 6 plus 5 over 2 lots of x. And that'll be fine as well. Okay, either of these answers are both absolutely fine. You can split the numerator. Next, looking at the coefficients to x here, they're all even, so we can divide out by a 2. We've got the lowest power with a matching base, so we've got x to the 7, x to the power of 4, x to the power of 3, so we're going to divide by 2x cubed. Okay, we can't divide by, say, 2x to the power of 7, because if we did, we'd end up taking 7 off this form, we'd end up with negative 3, and we don't really want negative powers at all. So you can always divide out by the highest common factor of the numbers and look at the powers of x and take out the lowest one. If there's y's, look at the powers, take out the lowest one. 6 divided by 2 is 3, x to the power of. 7 take away 3 is 4, over. 2 divided by 2 is 1. X to the power of 4 take away 3, which is 1. So we're going to get 1x to the 1, if you wanted to call it that. 4 divided by 2 is 2 with a plus, and x cubed divided by x cubed is going to be missing. Okay, so we'll get x to the power of 0, which is just 1. So you could tidy that up. You could give it as 3x to the power of 4 over x plus 2. Okay, we don't really need that though. Now, some people might be looking at this and thinking, hey, if I could split the numerator here, can't I split the denominator here? No, You never split a denominator. Never, ever split the denominator. Never, ever. It's a really, really, really important thing that you don't do. For example, if we know that 10 over 10 is equal to 1, should we split that into 10 over 2 plus 10 over 8? Split the denominator up, because that's the same, isn't it? That's 2 plus 8. We could try to split up the denominator. If we did that, we'd end up with 6 and 1/5, which is not equal to 1. Okay? It doesn't work. Do not ever, ever, ever split a numerator. It doesn't work. Okay? So don't split that. Next, look at the coefficients to x. 3, 2, 3, 1. Well, the highest common factor is going to be 1, so we don't really need to write anything on for that. We've got x to the 7, x to the 5, x to the 7, x to the 5, so we're going to divide out by x to the 5 because that's the lowest power that we've got. So we get 3x to the 7 divided by x to the 5. 7 take away 5 is 2, so we get 3x squared. 2, and then we've got these two things are going to cancel out, so we get plus 2 over 3. We've got x to the power of 7 divided by x to the 5 is going to be 3x squared. And x to the power of 5 divided by x to the power of 5 is going to be x to the power of 0, which is 1. Okay, that there was x to the power of 0, which we know is 1. Could we split the numerators up? Well, yes we could, but if we did, we'd end up with 3x squared over 3x squared plus 1. Wouldn't do anything. And we'd end up with plus 2 over 3x squared plus 1. Wouldn't do anything. We can't split the denominators. We're definitely not allowed to do that. And so that is as simple as it gets. Don't try to force it any further than that. Okay? So, thanks very much for watching. That was Index Laws from Year 1, Chapter 1, Lesson 1, the very, very first start of the algebra section for your pure part of the A-level in maths. Thanks very much for watching. There's going to be more videos and things like that going on this channel, but also head to numberclub.org to find videos and tasks which are going to be updated gradually over the next few months. Please like and subscribe to the channel. Hopefully it will help. Thanks.